Hey everyone, Bill Barhydt here. Welcome to another edition of Crypto Bytes. I'm really excited about this one. We've got a really special guest with us, so we'll come to in a second. And it's been a fantastic year for Abra. Thank you so much to the community who supported us. We've got hundreds of thousands of users now. Our community is growing every day. We just had our best month ever at Abra. We launched our index token, which has gotten huge adoption, the BIT10. Several weeks ago. We launched EOS a couple of weeks ago, native support for EOS inside the Abra app. So hopefully you all can go the EOS community and use Abra to make your EOS investments. And I'm super excited that we just launched native Ether support for the first time in Abra. So instead of just investing in Ether, you can actually do deposits and withdrawals using Abra as your core Ether Ethereum wallet. And so we think that this really sets the stage for Abra to go deep within the Ethereum community, and you'll see lots more announcements about our support for Ethereum-based contracts in the future. So I'm really excited about that. And I'm also super excited to have Vitalik Buterin with me. I guess you call yourself the founder of Ethereum. Mm-hmm. So I'm curious, first of all, thank you so much for joining us. I know I know the community is going to be super excited about having you join us. So how did you describe your role within the Ethereum project or community today? What is your role?
My role when I started was basically that I was the one who kind of came up with the initial idea. I wrote the white paper. I kind of sent it out to people, brought together the community initially. Right now, I probably focus the most on, first of all, kind of research problems. So we are, at some point, fairly soon, going to release an upgrade to Ethereum called Serenity, which will include the proof-of-stake consensus algorithm. So this is a kind of much more efficient form of consensus than the existing proof-of-work chain.
We'll come back to that.
Together with Sharding, which is this very large, maybe 1000x scalability improvement. And I spent a lot of my time on kind of figuring out the details of that upgrade, kind of figuring out what the protocol will look like and things like that. And I also end up kind of participating in kind of different other sort of strands of research. So things around like the cryptography, economics, like different Ethereum applications. I mean, I do also just go around the world and kind of talking to like different people in the Ethereum community and different kind of people in sort of larger and more mainstream circles that are interested in figuring out how to use Ethereum.
Are you having fun?
Yeah. This year has been great.
Cool. I want to talk about that in a minute. So I think just maybe take a step back, and I think a lot of our like traditional investors inside of Abra don't know a lot about you. So maybe if you don't mind, just introduce yourself, like where you come from, how you got into this in the first place, and how you went from writing about Bitcoin to even creating Ethereum.
Sure. So, I was born in Russia in 1994. 6 years later, moved to Canada. 11 years after that, heard about Bitcoin for the first time. I first heard about it from my dad, then I saw it again on the internet. I kind of thought, okay, this is an interesting idea. Maybe I should kind of poke into it more. I started kind of poking through the Bitcoin forums. I eventually found a guy who would pay me in Bitcoin to write articles for a blog that he was working on. From there, I became the co-founder of Bitcoin Magazine, which was this kind of website and print application that was around back during the kind of Bitcoin early days. Then I spent kind of about 2 years working on that and kind of getting deeper and deeper into the Bitcoin community, understanding of how it works on a technical level, understanding kind of the social and economic ideas.
So you're literally one of the few people who's probably spent close to half his life in the cryptocurrency world. I mean, you're probably like 24?
Yeah, 24, but like 8 divided by 24 is a third, so not quite a half.
Wow. But even that is incredible, right? I mean, for me it is, because when you were born, I was at Netscape, right? So, like the idea that you could even spend a third of your life, specifically not on cryptography, because I've been doing that as well since I was 19, but the idea that you could work on cryptocurrencies for a third of your life is incredible to me. What was your first programming language that you learned?
I remember when I was like very young, I would play around with like Excel spreadsheets, which is like kind of a programming language. Then when I was a bit older, I would do Logo and like C++.
Yeah.
No, the main thing I would program is just like programming video games that I would then play myself until I got bored. Then I would program more.
Right. Cool. Very cool. All right. So let's talk about Bitcoin and the segue to Ethereum. What attracted you to Bitcoin in the first place?
It just seemed like something that kind of gathered together all of the interests that I already have at the same time in one package. Like there was the math and computer science, the programming, the cryptography. The community back then was like very interested in kind of talking about different kind of political and social ideas, and there was kind of libertarianism was very strong, but then there were kind of socialists and like mutualist whatevers and all of these different fun little tribes, and there was even the sort of politics and society section of the Bitcoin Talk forum where people just debate these ideas with each other. Yeah, no, so Bitcoin kind of had that. It had this kind of these community with different ideas and like and a technology that actually could kind of actually have a big impact on the world. It had this kind of open source software aspects to it. It has this very interesting cryptography, so it seemed like almost a perfect storm for myself to get interested in.
Fantastic. And you had this idea that Bitcoin needed a more of a Turing complete scripting component to it, and that led to the idea for Ethereum. Is that a fair
what actually
fair
happened was that back in maybe October 2013, I spent some time working on projects like colored coins and master coins. So these were the existing layer 2s that were trying to kind of extend Bitcoin with more advanced functionality. And at one point I realized that like, hey, you could replace these 5 features with one other feature by just basically having a programming language instead of like these five specific like different transaction types. And it kind of came over time. Like the first thing I did was I made a proposal to Mastercoin that would replace like basically like 5 of the transaction types they have with a programming language designed to express financial contracts between 2 parties. So you could do like binary options contracts for different bets, like pretty much anything in that category with like one single type of thing. Then,
let's take a step back for a second. What was the attraction to you for this idea of having contracts, executable contracts at all, inside of a cryptocurrency-based model?
So initially for me it was like, hey, they're doing this thing, they're trying to make it possible to do more stuff. That seems cool. But I know how to do more, how to make it possible to do more stuff with a protocol which is 10 times simpler, which is instead of like basically having a Swiss Army knife with 100 different types of features, you just have a programming language and then you can kind of build whatever you want on top.
Did you have a vision where you said, oh my God, the world needs like this type of contract? Or was it more for you a holistic problem?
It kind of came over time. Like I started with these 2-party financial contracts. Then I kind of kept on mulling the idea over, and at one point I sent it to the Mastercoin people, and they said, yeah, that sounds cool, but like maybe we'll get to it in a year in our roadmap. And I was like, wait, a year? But don't you see this is like literally the most important thing out there? And I basically just decided to start working on it myself. So kind of free of the constraints of having to iterate an existing system, I kept on thinking, and eventually it took me a couple of weeks to figure out how to kind of expand the model from just 2-party contracts to just these computer programs that talk to each other and can do pretty much whatever they want. But once I made that one kind of leap, like it just suddenly everything made sense that like you can just do everything with contracts.
Okay, so now let's talk about that. So we have a lot of technical users of the Abra app, people who are watching this who hold Ethereum but don't really understand the deep difference between Ether and Bitcoin. So can you explain in kind of non-technical terms to the layman what is the difference between Bitcoin and Ether?
Sure. So Bitcoin is like kind of a special purpose blockchain. So it's good at basically the one thing that it does, which is kind of storing and kind of processing the transfer of Bitcoin balances. Ethereum is a much more general purpose platform. So Ethereum contains a built-in cryptocurrency called ETH, which you can use as a currency. But then it also has these smart contracts, which you can use to kind of implement a much broader variety of other kinds of blockchain applications, which could include financial contracts, it could include decentralized domain name systems, it could include like identity systems, their reputation, and so forth. And then there's this kind of big long list of blockchain stuff that people get excited about, and like basically any of it is like doable on Ethereum.
And how much of that, of what you just said, was the original vision versus how much of that has kind of evolved over the last 5 years?
I would say a lot. Like when I figured out how to move from kind of just two-party contracts to this kind of broader model of like contracts that can do anything, it became very clear that this was a kind of much more general tool than we realized you could do. And at that point, like other people in the community just started coming up with more and more applications. Like there were some people thinking up of decentralized file storage. There were people thinking up of like different ways that they could make their own tokens. I came up with some ideas around how to do things like decentralized oracles and so forth, and other people just took those ideas and started running with them. Part of that is like where Augur came from, for example.
Right, prediction markets.
Yeah. I mean, well, prediction markets are this other idea that just totally came from the outside, but like the platform is general purpose, and so even though I've never heard of prediction markets, when I did the platform design for the first time, you could still do them.
That's super cool. So what's I want to talk about some of the applications that you were alluding to in a second. But what's the craziest application of Ethereum that you've come across lately? Like just you're like this. I can't even believe that somebody came up with this. Like, is there something that comes to mind?
I mean, I'm definitely impressed by MakerDAO. Like, so what MakerDAO basically is it's just a kind of smart contract system that issues a currency which is kind of pegged in value to the dollar, but it's not dependent at all on kind of any outside banking systems or anything like that. Like basically there is an even larger kind of pool of ETH that the contract maintains, and the contract like basically maintains this kind of peg where it has this data feed that feeds in the price of ETH to US dollars from the outside, and depending on what that price is, like that's the amount of ETH that you can kind of recover from one DAI. And what that basically means is that you get this kind of cryptocurrency, which is a sort of pure cryptocurrency in the sense that it doesn't depend on centralized infrastructure, but it has a stable value.
Sure.
And like theoretically, you could extend this kind of model to not just US dollars. Like you could have exposure to arbitrary assets, you could have exposure to like CPIs, you could have exposure to real estate indices. So there's but the interesting thing about it, like the idea is something we knew about for a couple of years, but like they actually did it, and it actually works, and it's like worked for almost a year. And I think it's going to be a year and like maybe even a week or so. And the price has just like actually stayed at $1 all the way through.
That's awesome. Actually, there's a lot of similarities between what MakerDAO is doing and the Abra platform using Bitcoin, because we basically use multi-sig Bitcoin contracts to create our kind of stable assets. The dollar, even the ETH up until now was basically this stable asset model using Bitcoin, although now it's a native Ether wallet, of course. So let's talk about some of those applications. So obviously this has been a crazy year from kind of a venture capital, ICO perspective, right? So I'm curious, like, what is your perspective on what's happened in the past year in this crazy ERC20 market? And is that a viable, interesting application of Ethereum going forward, or do you think that that's kind of going to die?
I think there's definitely going to be even more ERC20s that just keep on getting issued in the future. I mean, I do think that the kind of age of like multi-$100 million ICOs has passed, at least for quite some time. And honestly, I'm very relieved about that. There's definitely a lot of different use cases for issuing tokens. Like one, you could use them to kind of represent assets. So things like these different stablecoin projects. You could use them for like assets inside of video games. You could use ERC 721s to like non-fungible tokens to kind of represent digital collectibles. And you can use ERC20s to represent tokens which have value inside of some applications. And like I do think that kind of the app coin thing has been kind of overhyped and overused, but there definitely are some areas where I think it's totally legit.
Yeah. So we'll come back to the 721, the collectible model, in a second. I think that's a really interesting topic as well. So on the ERC20 topic, what do you think about like just traditional securities enabled via the ERC20 model, not just like issuing new tokens to fund a company, but taking like existing stocks and making them available via ERC20? Is that something that you foresee happening en masse in the future?
Yeah, I think that's like a totally cool idea.
Yeah. Are there startups that you're aware of that are actually trying to do that now?
For stocks, I don't know. Like, the challenge is, right, that you want these stocks to kind of be issued natively. Like, you actually want the record on the Ethereum blockchain to sort of be the authoritative thing that, like, tells the court who actually has the legal rights. And that's involves legal engineering more than anything else. I know there was this company based in Singapore called Autonomous that was trying to just do kind of company share management on Ethereum. And, like, part of the long-term vision for that would be that you can just have stocks that get traded on the blockchain, but then that particular company shut down.
Right. When you think about like mainstream adoption of decentralized applications or any application that takes advantage of Ethereum, what do you think it's going to take for true mainstream adoption by the average consumer or institutional investor? Are they going to know that they're using Ethereum? Is it going to be relegated to the background? And how much of that is dependent upon your development platform community versus the actual app developers?
I would say in some cases yes, in some cases no. There's definitely ways that applications can benefit from Ethereum without kind of exposing the user to any blockchain bits, but then there are also other benefits that you really can only get by kind of making the blockchain parts closer to the user side. As far as the big problems, my top three at this point are probably scalability, privacy, and usability. So scalability, Ethereum blockchain right now can process 15 transactions a second. Really, we need like 100,000. Privacy, like every single thing you do right now is like totally public to everyone, and that just like doesn't do for a whole bunch of use cases. So this is part of why like we're working on some like fancy cryptographic technology like ZK snarks to try to solve that. Usability is like a super big challenge. A lot of blockchain applications are just like very poor on the usability side. They have a lot of kind of hiccups and like, oh, why did this suddenly just totally not work? Why did this take 10 minutes longer than I expected? The other big challenge that I care about is kind of usability of security. So coming up with easy to use ways for people to store their private keys that don't become vulnerable to like someone just losing everything because they either lost their private key or their private key got stolen. And there are some interesting solutions that are coming out to that, but it'll still take a couple of years for all of these different strands to get somewhere. Yeah,
we struggle with the last one a lot. I mean, we force our users to actually write down the backup phrase, to recreate the wallets, and we have obviously near 100% compliance with that because we don't give the user a choice. But it is not, a kind of fun, friendly, process for our users. So let's kind of work backwards on what you were talking about earlier. So actually, let's start from the top. So you mentioned scalability, that it's going to take probably 100,000 transactions a second, at some point to really make Ethereum useful. Where are we now in terms of getting from 15 transactions a second to 100,000 transactions a second in the Ethereum network?
Okay, so there's kind of two major kinds of strategies that we're working on for scalability. One is kind of layer 1 scaling and the other is layer 2 scaling. So layer 1 scaling basically means kind of improving the blockchain protocol itself to allow it to process a much larger set of transactions. And the main bottleneck with blockchains right now is basically like every user has to download the whole blockchain, which basically means the blockchain can't hold more transactions than one guy's computer can store. And our solution to this called Sharding basically means that you kind of split up the different transactions to just randomly selected kind of different groups of computers. And this basically means that the blockchain can process way more things than one single computer can hold. And that could increase scalability by, maybe a factor of 1,000 or so, but then potentially even more later, or much later down the road. The other kind of scaling that we are working on is a layer 2 scaling, which basically means kind of designing applications in such a way that not everything that happens actually goes on the blockchain. So basically, instead of going to the blockchain every single time any user does anything, you perform most of your operations off-chain using just cryptographically signed messages, and you only need to put data onto the chain when there actually is some kind of dispute.
Yep.
So there's two major classes of systems that we're working on in this regard. One is called state channels, and there's a bunch of teams working on this. There's a team called L4 in Toronto that's done some really good work, and another project is Plasma.
Sure.
And there's a lot of work that's been done on that. You know, MiseGo is this like decentralized exchange that was it's building on Plasma. There's like thematter.net. There's more and more of these projects, and then there's like one of our researchers, Carl Forsch, has been working on a kind of implementation of a reasonably complete kind of Plasma Prime specification, which is the latest version of Plasma, which has some really cool features in terms of increasing scalability and reducing the amount of data you have to store.
Yeah. So a question on-chain scaling. So the Bitcoin core world, for example, beyond SegWit, has really relegated scaling to layer 2, right? Which means off-chain scaling. You obviously have a very different approach for Ethereum. Do you think that the approach that the Bitcoin core community is taking makes sense for Bitcoin, or should they have the same perspective as the Ethereum project, in your opinion?
I mean, if Bitcoin wishes to kind of just be a store of value, then I mean, realistically, it's probably fine, though I think they should switch to proof of stake. If they want to actually be a currency that people use for transactions, then I do think like base layer scaling and also kind of speeding up the blockchain, reducing block times at the base layer is also something which is very important. There are serious limits to what you can do at layer 2. There's limits to usability of layer 2, and there's attacks on layer 2, and also the other thing to keep in mind is that the scalability of kind of gains from layer 1 enhancements and using layer 2 are multiplicative. So if layer 1 can be made to be 1,000 times more scalable, that's also 1,000 times increase in the amount of transactions per second that you can push through a layer 2 thing safely.
Sure.
Yeah.
But I also think that there are legal implications with layer 2, because you get into like money service business and e-money regulation there.
Yes.
That I think a lot of the developers who don't come from the legal world don't fully understand.
Yeah, oh, absolutely. Like one of the kind of benefits of layer 1 things in general is that they literally just do not depend on like operators. They don't depend on like infrastructure. They just work directly on chain. Right. And that basically, I mean, first of all, reduces legal risk for a lot of people, because you just need much fewer entities, and possibly just no entities that even can be classified as operators. And also, even in the absence of legal issues, it makes the whole thing more robust, because you don't have to kind of wait for these operators to start existing to count on them to exist, to kind of count on them to not kind of coalesce into one single one because of network effects, and then charge monopolistic transaction fees and like all of these issues.
Sure. So let's segue now into the privacy issues you mentioned. So how do you think, how do you personally think about the privacy requirements for smart contracts and the Ethereum model? And are there legal implications of your perspective that need to be taken into account, or is it all about just doing the right thing for the protocol, and the legal stuff will work itself out over time?
So first of all, I think it's important to keep in mind that in the Ethereum context, Ethereum is a general purpose Turing complete blockchain. And so what that means is that any of these privacy preserving protocols just can be done at layer 2. So we, as kind of designers of layer 1, don't technically even need to do anything to make it possible for these layer 2 zero knowledge payment protocols to actually work.
Right.
So in some sense, what that means is that like as long as there's people who kind of care about privacy just anywhere in the ecosystem and keep pushing it forward, it will happen.
Yeah.
And it also means that like kind of at layer 1 we don't really need to make choices of, do we like ring signatures or zero knowledge proofs or confidential transactions or rapid signatures or whatever, like fancy cryptographic buzzword of the week.
Sure.
And we can just have a programming language, and other people can experiment with all of the designs.
Yeah.
From a legal point of view, I mean, I know there definitely are kind of regulators in different places that are kind of more concerned about the kind of zero knowledge coins than about kind of tokens where all of the transfers are kind of put onto the blockchain in plain text. And it is something that like the kind of possibility of these technologies is something that just kind of is going to happen over the next couple of years. And I do expect that for some classes of tokens, especially the classes of tokens that are kind of closer to having more dependence on kind of traditional institutions, so this would be security tokens like asset-backed stable coins and so forth, and regulators may end up kind of demanding that they set up like their privacy in some way that like allows the regulators to see different parts of transactions, and that's also something that's kind of inevitable.
But this idea that in the Bitcoin world, this is a problem as well, right? I mean, we talk about fungibility of a token, meaning that if I have a unspent output for Bitcoin or for ETH that basically traces back 6 steps to a public address that belonged to a drug dealer that was arrested, that somehow I'm culpable in those transactions because I'm still using that token, which by the way is a problem with paper money, because if you look at the average paper money, it's got traces of all kinds of drugs on it. It's actually disgusting, right? So is it the protocol developers or is it the Ethereum project's responsibility to deal with that fungibility issue so that becomes a non-issue?
I feel like our design philosophy for the Ethereum protocol is kind of layer 1 must be strong, but layer 2 is ultimately the more innovative. And so like we don't need to kind of explicitly make all Ether transfers privacy preserving or whatever at layer 1, and like that honestly can't even work because like Ethereum contracts need to use ETH, and Ethereum contracts can't even hold secret keys, so there's no way to make that kind of privacy preserving, and what does that even mean? So the thing that you can do, of course, is like all of this different layer 2 innovation. And if I know in general, like in common law, there is this kind of legal principle that fungibility of like currency is sort of enshrined into law, right? Because for normal assets, like for example, there's this kind of nemo dat quod non habet principle, which is basically like if you steal a bike and then you sell me a bike and then I give the bike to Carl, then the original owner can totally just go to Carl and say, hey, that's still my bike, given back to me, even though Carl himself technically did nothing wrong.
Right.
But with currency, that's kind of explicitly overwritten in the law, so it's explicitly designed to treat every $10 bill as being identical to every other $10 bill. And in the case of cryptocurrency, and I don't think there has been a kind of very specific case about this, but I know they are classifying it as property, which does mean there's some risk that they'll try to kind of treat specific tokens differently depending on where they seem to come from.
Sure.
And I mean, privacy preservation is definitely one way to just make it kind of less feasible to do things like that, which I think is definitely a kind of gain for the usability of the platform as a whole.
Yeah. So that's an interesting kind of segue into this idea of governance, right? Everybody, I mean, last year we went through this whole kind of SegWit 2x debate in the Bitcoin world, and obviously you guys went through the proof of stake and plasma debates as well in the Ethereum world. How do you think about governance? First of all, what does the word governance mean to you? And how do you think it should apply to a decentralized protocol like Ethereum?
Sure. So blockchains are interesting because they are this kind of fundamentally new class of like thing. whether an organism, meme, like whatever word you want to use. Like,
Yeah.
they're kind of like corporations, but also not quite like corporations. They're kind of like countries. They're also not quite like countries. They're kind of like open source projects, but not quite like them.
Right.
They're kind of like religions, but not quite like them. And they combine elements of all of these things and add some new ideas and kind of elements of their own.
Yeah.
So the kind of properties that matter, I think, with blockchains are that, like, they have this property of open source software that, like, ultimately the value of the thing is entirely kind of what people assign to it, and at the end of the day, if you want, you can fork. But compared to open source software, I think there are also stronger disincentives against forking. And if forking is infinitely difficult, then you get back to governance of things like corporations, right? So I think blockchains are sort of in the middle between those two. I view governance as a kind of coordination process. So the idea is basically that all of the users in a blockchain ecosystem are kind of playing this game where they just keep on deciding every day basically what software they're running. So, am I running Geth? Am I running Parity? Am I running Bitcoin ABC? Am I running Bitcoin SV? Something else? And the one property that this game has is that you benefit from just making the same move as many other people are making, right? Like if I run a version of the Ethereum clients that issues an extra 20 million units of Ether to me, it might seem like I benefit because I get 20 million Ether, but I lose because really nobody else values that Ether, and I'm just going to get forked off of everyone else's chain. So because governance is this game where everyone benefits from sort of making moves in concert, there's a huge number of different kind of equilibria that can arise inside of this game, right? You could have the equilibrium where everyone runs the same software forever. You could have the equilibrium where everyone runs the software that I tell them to run, and I say something on Twitter that points to a new version, and that's the version everyone downloads. You could imagine an equilibrium where there's some group of core developers. You could imagine like miners having a hash war to vote.
Right.
There's and like each of these equilibria are sticky, right? Like once the system kind of falls into one of these equilibria and people have the expectation that it is this way, then single individual has an incentive to act in that way because they benefit from being in the same universe as everyone else.
So ideally, I guess what you're saying to some degree is you're aligning incentives if you do governance correctly. Right?
Yeah,
in
basically governance is this kind of ultimately it is the question of what specific equilibrium should we be in right now.
Right.
And within one of these equilibria, if you want to kind of cause some change to happen or prevent some change to happening, then like how do you do that?
So let's talk about governance and decentralization, right? So to me, the litmus test to have a decentralized protocol on the internet is probably two things in my mind. Maybe you agree or disagree. One is there a central off switch, right? And two, can I stop the developers from actually contributing to this decentralized thing that has no central off switch? So I think about BitTorrent as kind of the first project that passed the litmus test for me, where you couldn't really stop either. The government's tried, right? Do you think that we've achieved that with Bitcoin and Ethereum, where there's no central off switch that would allow you to really shut it off, and that you couldn't really stop the developers from contributing if governments didn't like what they were doing?
Yeah, actually, I am not worried about the blockchain being kind of shut off from a development side because, like, first of all, there's lots of people running nodes, and even if the developers just all go poof in a puff of smoke, then people can just keep on running the same client version forever.
Sure, but with the bugs that they had before, right?
Yes, and then if bugs come up, then there could be new developers that would kind of pop in, and like it will take longer to fix, but it would still get fixed. Second, in Ethereum, we've taken really great care to ensure that there are multiple implementations of the protocol that people actively use.
Yep.
So in Ethereum 1.0, we have Geth, the Go version, and Parity, which is this independently developed version in Rust. And there are others that people use them less, but people could start using them more. For Serenity, so this is the upgrade that adds in proof of stake and sharding, that's gone up to something like 8 implementations, and there's like 8 different companies that are working on implementations. Like one in Python, one in Rust, one or two in Java, and a couple of others, one in NIM.
Yeah.
So that basically means that even if one development team kind of goes down, the others can keep going. Now, I think shutting down is not the only risk you need to be worried about. The other risk you need to be worried about is capture. So can
define capture.
Yeah, so basically, can a small group of actors kind of gain enough power inside the decision-making process to ensure that, like, basically things go their way, and especially if their way might not be aligned with the way that, you know, the community of the blockchain actually wants?
Or a simple attack and something
Yeah,
similar, right?
yeah. Well, the exact kind of attack depends on what your exact mechanism is. So, like, for example, if you have a community where the religion is that 51% hash power decides, then you can just totally break and capture it by getting 51% of the hash power.
Sure.
If you have something where some small group of developers decide, then you can, like, either be one of those developers and kind of get a cabal together, and or even just kind of create an ideological orthodoxy that this is the way to do things.
Right.
I mean, or you could try to kind of join this group over time. You could even try to kind of hire them as a company. You could try to influence them in a bunch of ways.
But a 51% attack, in at least to the usefulness of a network for Abra, is almost the same thing as having an off switch, because at that point the network is no longer useful.
Well, there's different kinds of 51% attacks, right? So, like, for example, you can do a 51% attack that just makes the blockchain break, but I can also do a 51% attack that censors all transactions, except for those transactions where the transaction fee is at least $100.
Yeah.
And if I do the second one, then that's something that makes the blockchain still kind of useful, and maybe people will just keep on paying the $100 and it'll be super profitable for me.
Right, fascinating. So are you convinced that we've reached the point where either a 51% attack or just some kind of, like, government collusion to shut off the networks is just no longer possible, specifically for Ethereum?
I think, like, if governments collude to try to bring the network down, they could probably do it, and developers would have to kind of actively fight back and keep trying to make different network protocols and so forth, and that's something that would just kind of keep on happening. I mean, fight off government attacks without active developers, I think realistically we're totally not there yet.
Yeah.
And that'll probably take much longer.
Right. Probably another podcast or video session. Fascinating topic. I love that topic. I think that the libertarian in me wants a fully decentralized network, but I also realize that, you know, we're getting there in very logical steps that also have to safeguard the value of what people are using the network for in the first place along the way. So this has been kind of a heavy conversation. Maybe just like we can close it out by lightening up a bit. So I'm curious, do you have, like, hobbies outside of Ethereum? Do you read a lot?
Yeah, and I definitely do read. I try reading books just, like, during those times when I'm either, like, traveling or someplace where I can't be productive on something else.
What do you enjoy
right
reading?
now I'm going through Jane Jacobs' The Death and Life of Great American Cities.
Yeah, so you just like to stay with the heavy stuff, huh?
I guess. No, I definitely try kind of mixing my entertainment with, like, learning or keeping up my German or, like, weird things like that.
Yeah, awesome.
And the lighter thing I do is probably going on walks.
Yeah, you're a hiker?
Yeah.
Right on. Well, we'll have to pick up this conversation over a hike. I've spent a lot of time in the mountains, so I'd enjoy that. So look, this has been awesome. I could talk to you literally all day about this stuff, but I think we'll stop there. This has been, like I said, fantastic. Thank you so much for the time and for everything that you do for the community. And obviously you're a representative of a lot of awesome developers, and we are very grateful to the entire Ethereum development community for everything they do. We're really excited about going deep within not only supporting ETH, but the Ethereum platform at Abra. You know, we didn't really get to dig in too much on the kind of CFD swap model. We should do another conversation with that. I think we could probably spend an hour just kind of talking about financial products, which I think for a core part of our audience would be interesting. So thanks everyone for joining us this episode of Crypto Bytes. This was super fun. Check out the new ETH support in Abra. You can literally transfer your ETH to the Abra app, use it to invest in other currencies, buy other currencies, store your ETH, and have a great holiday. And we'll talk to you soon. Take care, everyone.